Hi again, physics class. Today I'm going to introduce Kepler's laws to you. Okay, in the year 1600, this guy Kepler, he went to work for a famous astronomer whose name is Tycho Brahe. Now, you probably have never heard of Tycho Brahe, but I assure you, very interesting guy. Head on over to his Wikipedia page if you want to learn more about Tycho Brahe. He lost part of his nose in a sword fight, a duel, at a wedding where he disagreed with something about math. He died at a party he was hosting because he didn't go to the bathroom. He was not excused from the table. He was waiting for kind of the honored guest is supposed to be the first one to leave the table. So he missed his chance to go to the bathroom. It turned septic and he died from that. Plenty more interesting facts about Tycho Brahe. He lived in a castle. He had a pet elk. Interesting fella. Anyways, let's talk more about the science behind all this. So Tycho Brahe, he was an astronomer. He kept meticulous records of the position of planets and stars every single night for decades. He took incredible records. All right. He asked Kepler, who was a mathematician, to go over the data for Mars's orbit because it didn't quite follow the mathematical predictions that Brahe had modeled. So he had decades of positions of Mars, and he couldn't actually predict exactly where it would be in the sky when it returned, and that would be bothersome. So he was asking Kepler to try to figure out what was going on, and Kepler figured it out. He resolved the issues with Brahe's model by making two assumptions that Brahe did not. Okay, so Kepler suggested that Mars revolved around the sun. Tycho Brahe kind of developed a really strange hybrid model of the solar system where planets revolved around the sun except for Earth, and then the sun, along with all the planets, revolved around Earth. It seems convoluted, but Tycho Brahe was kind of like a nobleman. I think part of the reason he came up with such a weird scheme was just to not upset the church, because he was an influential guy, he got a lot of money, and maybe didn't want to upset people. Okay, number two, this is the big one, is that Mars's orbit is an ellipse and not a circle. I'm sure you've heard the word ellipse before, but it has a mathematical definition I want to show you. So it's like an elongated circle. Okay. I tried to trace the bottom of a bottle for the circle. It looks terrible, but it's not bad. You all know what a circle is. You can define it as just the shape traced out from an equidistant from a single point. That's the center of the circle. The radius is constant, right? That's how you could define a circle. For an ellipse, you start with like two centers, and you add the two radii, you can call them, and that sum is constant all the way around. If these 2 points are farther apart, you get like a more irregular shape or a longer ellipse. If they get closer together, the ellipse looks more like a circle. If they're in the same spot, it is a circle. So in fact, a circle is actually a type of ellipse. Okay, these two centers are called foci. A circle is an ellipse with only one focus. And this is the shape of orbits. Kepler figured it out just by looking at data. Later, Isaac Newton proved it with his theory of gravitation, that orbits are elliptical, not circular. Although circles are ellipses, so many orbits are very close to circles, like Earth. I'll talk more about elliptical orbits in the next video.